Now let's look at this question together. The quantity of electricity that will liberate 0.125 mole of oxygen molecules during the electrolysis of dilute sodium chloride is dash. A, options that we are given is A, 24125 coulombs, B, 72375 coulombs, C, 48250 coulombs, and D, 96500 coulombs. So how do we go about it? Remember, I told you that at times you may be given your question in moles, and that is it there. Now remember, let me quickly remind you of how we derive that. Your molar mass, your mass is going to be what? Relative atomic mass, right? Multiplied by Q, remember, all over N times Faraday constant. Then when you make Q the subject of the formula, what do you have? You have your Q to be what? Your M multiplied by N, we've done this before, so you should be able to remember it, multiplied by Q all over relative atomic mass. You still remember? Then I also remind you that mass over molar mass is the same thing as your mole, number of mole, right? So if that should be the case, our Q here will now be equal to my mole multiplied by my number of charges times my Faraday constant. So this is the formula we'll be using for this particular question. But before we do that, let's look at, we already have our Q. So this is the formula we'll be using for this question. Now, we are asked to calculate quantity of electricity, which we don't know. We already have our mole to be 0.125. Mole to be 0.125, right? Then any other thing? No. But from here, we already know that our Faraday constant is 96500, right? Now the question is, what is our number of charges? Now that will take us quickly back to the electrolysis of sodium chloride itself. Remember, normally sodium chloride will dissociate or will break down to what? Na plus, Ab plus Cl minus, right? Then also in that same particular reaction, or in that same particular electrolysis, we will also have my H2O. We also break down to what do we have? H plus, Ab, right, plus OH minus, right? Because they said dilute. Now from here, I'm not after hydrogen, I'm after OH here. My OH here will give me what we call H2O plus O2. When you balance this, we are going to have 4OH and 2H2O. Look at it. 4 hydrogen here, 2 times 2, 4 hydrogen. 2 oxygen here, 2 oxygen here, making 4. Then 4 oxygen is balanced. But it's not yet balanced because the charges has not been balanced there. So let's balance the charges. We have 4 charges here. That means 4 electrons here. So let's balance it here. So it's going to be plus 4 electrons. So it means that the number of charges for this particular oxygen molecule, remember they put molecule there, and this is a molecule, oxygen molecule, that 4 Faraday is needed to liberate oxygen molecule. So from there we can now calculate now. Now let's write the formula again. The formula is Q equals to mole multiplied by number of charges multiplied by Faraday constant, right? So it means my Q is going to be, I've told you our number of moles is 0.125 multiplied by my number of charges. Remember, I told you that 4 Faraday will be needed to liberate oxygen molecules. So my number of charges now is going to be 4 multiplied by my Faraday constant, which is 96500 coulombs. So at the end of the day, when you press your calculator, what you're going to get is 48250 coulombs. And do we have that option in our question? Yes, we do, which is option C. So our answer is C. I believe it is clear. So let's look at another question. Then after that question, I'm going to give you another question for you to work on. Then you send your answer to me under the comment section.